In this quick video, we're going to look at how to apply a regression to these lines to get our a, b, and c constants for the quadratic equation. So we're going to scroll down here using the data that we generated from our video clip in the last video, and we can see we have our horizontal movement displacement going up pretty quick. Its rate of change is increasing much faster than the vertical rate of change, which is this blue line. So let's put a quadratic line through these so we can see it, and we can get our constants as well. So tackling the horizontal data first, these green dots, we can see that it's a combination of x1, y1 data points or pairs. So we can scroll down here, and on line 3 we can start to type an equation. And because this is the x1, y1 data set, we can say something like y1 is approximately equal to a, because we're going to follow that same standard equation. And we're going to go x1, and we're going to use our shift 6 to get the exponent and put in 2. And we can see the quadratic or the parabola showing up on the right hand side. And then what we're going to do is hit our right arrow to exit out of the exponent, and we're going to go plus bx1, reminding ourselves that x1 represents the x data of this table 1, and then we'll go plus c, and we can see that we have a nice fit line now for our data points. And if we scroll down a little bit, we can see that it gave us some regression parameters. So the a, b, and c have been calculated to be these numbers down here, and we'll use those in a future video to generate our velocity time graph. And we can see that the r squared value is 0.9997 for this lab, as long as you're above 0.95, or even honestly 0.9 or 0.92, you're okay. If you get down to 0.92, 0.90, it's probably because one of your data points at the start or end of the video was quite a ways off from everything else. So rather than deleting one data point, because we have limited data points today, I'd rather you just aim for anything above 0.9, but in our ideal situation, you're above 0.95. Okay, so we do that, and then if we want to regress or put a regression on our second line, we can scroll down here to line 4, and knowing that this is an x2, y2 data pair for that plot, we can just type in the same thing like we did a second ago and just change the subscripts. So we can go y2 is approximately equal, and I should note that that approximate sign, the tilde, is on the top left of your keyboard. You have to use shift to get it, and then we can go ax2 shift 6 to get the caret sign to give us the exponent, type in 2, right arrow to exit, and then plus bx2 plus c, and now we can see we have another parabola generated with different a, b, and c values for the standard equation. And again, the r squared value, as long as it's above 0.9, we're good for today's lab. You're looking for above 0.95, but we actually have 1, so this is a really good fit. Take these values, write them down in your lab notebook. You're going to use them in the next video.